The last thing that we need to do for this problem, and the most important thing that we need to do for this problem, is interpret the confidence interval in the context of the problem. When we're defining the confidence interval, remember that we're giving a reasonable range of values for the population proportion dependent on the value of the statistic that we calculated. We're only 90% confident in this case because of the length of the interval that we originally created. The interpretation that we generally use follows the following form. We are 90% confident that the true proportion of people that believe in love at first sight is between 0.564 and 0.636. Some of the important pieces of information that we get out of this are, first off, how confident we are. So you'll always put in the value of your confidence into your statement about your confidence interval. Second, you need to tell what parameter we are trying to describe. When we first started looking at statistics, we decided that we needed to know what the parameter was so that we could talk about what we needed to collect for the data. So the parameter is a statement about the mean or the proportion, or in this case it's just the proportion, and it would be the true proportion of people that believe in love at first sight. Remember that we were very specific about the parameter when we described it. So it would be the entire statement, the true proportion of people that believe in love at first sight. And then we give a bound, a lower bound of 0.564 and an upper bound of 0.636, which means we would expect the true proportion to be somewhere between those two values. We have a 10% chance of being wrong simply because the statistics that we created might have been on the endpoints or out in the extremes of the interval.